So you look at question 49 here tells us that if x raised to the power 3 minus xy plus y cubed is equal to 1, find dy dx. So begin by differentiating each of these terms. So we differentiate x raised to the power 3. This will give us 3x raised to the power 2. Right? So remember how to do this. 3 times x, then raised to the power 3 minus this to the power 3 minus 1. Alright, and then minus here we have we're going to apply product rule. Differentiate x. If I differentiate x, I have minus y left. Okay, I have minus y. Alright, to differentiate x, I have 1 times y gives me minus y, and then I have, okay, plus. If I differentiate y, I will have minus x left, so this will give me minus x dy over dx. So remember to always put the y over the x to this particular term. Okay, so this is what I have, and then I go over again here. This will give me 3 y raised to the power 2, and then also having dy over what? The x, and all of this is equals to 0. Alright, take note of that. So this is what I have. Okay, now I'm going to take like terms, because here I have dy dx, here I have dy dx. So I'm going to take all the dy dx to the left hand side of the equation, and if I do that, that will give me, I'll have 3y squared minus x into dy over dx. So this is 3y squared, and then I have here to be minus x. Okay, so these are all a function of dy dx, and then I'm going to move all of this other term to this side. Right, so this way, so I'm going to move everything here. I'm going to move everything here, okay, over to this other side. That will give me is equals to minus into 3x squared minus y. So dy over dx goes ahead to give me minus 3x squared minus y, all divided by 3y squared minus x. So this happens to be the answer to this particular question. Alright guys, so this is the solution for this problem. I hope you understand this. Alright, so let's continue. Let's move over to the next question, that is question 50. Alright, in question 50 here, over to question 50. Okay, question 50 says, if 2x plus y squared equals to x plus y, find dy dx. Find dy dx. Okay, so this is going to give me, if I differentiate this, I'm going to get, this is a product rule. So if I differentiate with respect to x here, keeping y constant, I have 2. So this gives me 2. Okay, right, let me change that color. So if I differentiate this with respect to x, this will give me 2. Then the differentiation of 2x is 2. 2 times y will give me 2y. So here I'll have 2y. Okay, let me do that again. This will have 2y into dy over dx. And then if I differentiate with respect to y, I will have, okay, take note please, take note please. So I will have 2y. If I differentiate with respect to x, I will have 2y, and then plus, if I differentiate with respect to y, I will have 2x. Differential of y is 1. 1 times 2x, this will give me 2x, then dy upon the x. So this is what I have here. And then plus, if I differentiate with respect to y here, this gives me 2y into dy all over the x. And then it's equals to, if I differentiate x here, this gives me 1. Okay, and then if I differentiate with respect to y, this gives me just dy upon the x. Well, that's probably 1 here. Okay, so I take it again. If you differentiate with respect to x, the differentiation of 2x is equals to 2. So 2 times y gives me 2y, and then plus, if I differentiate with respect to y, keeping x constant, I will have the differentiation of y is 1. 1 times 2x gives me 2x dy upon the x. Then plus, if I differentiate this with respect to y, I'll have 2y. But take note, all the y terms must, whenever I differentiate the y term, I must maintain my dy dx. So I come over here, I differentiate x, this gives me 1. I differentiate y, y gives me 1. So 1, probably have a coefficient here, an invisible coefficient here, which is 1 to y s, but mathematics we don't write that, so that's why I didn't bother on writing the 1. Okay, so if we go ahead from here to take like terms, so you could see that this is common with this, so this and this are all common. So let's start by doing all of that. So I'm going to bring everything to one side. This is going to give me, so this is going to give me 2x. Okay, let me use it. This is going to give me 2x dy over dx plus 2y dy over dx. Then this comes over, becomes minus dy over dx, and then everything on this other side goes to give me 1, and then this gives me minus 2y. All right, so this is what I have here. And then if I go further from here, this is I'm going to, this is the y, this is the y, this is the y. So the y is going to be a common denominator here, so this is going to give me 2x plus 2y and then minus 1. Okay, or function of what, dy upon dx is equals to 1 minus 2y. Right, so this is what I have. So I'm going to go ahead to find dy over dx. So it means that dy over dx is going to give me, I divide both sides by 2x plus y minus 1. So this will give me 1 minus 2y all over 1 minus 2y, and then this will give me all over 2x plus 2y minus 1. Okay, so this is basically what I have as my solution to this particular problem here. So this is the answer to this equation. All right, so don't forget we started by looking at this equation we started with, then we differentiate each of these terms, all right, implicitly. So differentiate x and then keep y as a constant, and once you're done you differentiate y and then keep x as a constant. Do the same thing here, differentiate y here. Take note that the y term must always retain the dy dx, and then you come here, differentiate x, you get 1, differentiate y, you have 1 dy over dx. So once you do your algebra and then you collect your like terms, you arrive at this